All right, as we segue into multiplying fractions, you'll notice that there are some differences. With multiplying fractions, all we do is multiply straight across. That's both the top and the bottom. We're multiplying straight across. That's one of the big differences between add and subtract. Uh, with add and subtract, we added or subtracted the tops and we kept the bottoms. Okay. With multiplying, we just multiply both numbers straight across. The other thing is, you do not need to have the same bottom number when multiplying fractions. That makes it a little bit easier. So keep in mind, like when we added and subtracted, you had to have the same bottom number. In this case, you do not. We could just multiply the top number and the bottom number straight across and we'll be in good shape. Now, if we look at the problem I have right here, incredibly easy. Okay, if I multiply straight across, 2 times 4 is 8, 3 times 7 is 21. I can't reduce that. That's my answer. Now, we're going to go a little more in depth with this, and it gets different when we use mixed numbers, and that's what the next section will be about. So this should be pretty easy. There's just a couple of other things that I want to add to it. All right, I've put this problem on here twice for a reason. We could simply just multiply straight across, okay? And we're going to do that. Remember, we don't need common denominators. We're multiplying the top and the bottom straight across. So 4 times 20 is going to, of course, be 80. And then 5 times 30 is going to be 150. And we will need to reduce those. You could divide by 2 probably a couple of times, or maybe once anyway, then you'll have to find something else. You could divide by 5. If they both end in 0, I can divide by 10. Okay. 80 divided by 10 is 8. 150 divided by 10 is 15. 8/15 is my answer. Now, something that you can do that is kind of special when we're going to do multiplying and dividing. You can do what I would call, I don't know, some people call it cross dividing. You could call it cross reducing. We'll call it cross reducing or cross dividing for now. But what you can do is, if you look at the fractions that are diagonal to each other, or not the fractions, but the numbers in the fractions that are diagonal, like the 5 and the 20 are diagonal to each other, and the 4 and the 30. If we can reduce the diagonals by a number, that means we'll have less reducing to do at the end. Let me give you an example. 4 and 30, there is a number that goes into 4 and 30, and that would be 2. So if I want to, before I even do this problem, divide both of those by 2, I can do that. Cross division or cross reducing. So I'm going to go ahead and divide both of these by 2. 4 divided by 2 is 2. 30 divided by 2 is 15. Okay? Now, it's possible I could do it with the other pair of diagonals. What's something that goes into both 5 and 20? Well, 5 goes into both 5 and 20. So if I do 20 divided by 5, I get 4. If I do 5 divided by 5, I get 1. Now, the purpose of that cross reducing is you have a much simpler problem at the end to multiply. 2 times 4 is 8. 1 times 15 is 15, and there's my answer right there. 8/15ths, I don't need to reduce it at all because it's already reduced. That cross-reducing part that I just showed you, that's optional. You don't have to do it, but you'll find out it's a good tool to have now, because when we start working with the mixed numbers, the numbers are going to get pretty large. Doesn't mean you can't still do them, but this cross-reducing thing, I think, really can help make the problem a little simpler. All right, in our next problem, again, with multiplying fractions, we don't need common denominators, so we're set. We just need to multiply straight across. 10 times 2 is 20. 14 times 3 would be 42. Okay, there's our answer. We just need to reduce. And I would say we could divide by, how about 2? 20 divided by 2 is 10. 42 divided by 2 is 21. 10/21 is my answer. Now, I put another one down here because we can do that cross-reducing on this one if you want to. You don't have to, but I think it's a good thing to learn how to do. So, cross-reducing, I need to look at the numbers diagonal from each other. The 10 and the 3, we're not going to be able to do anything with that 10 and the 3 because there's not something that goes into both 10 and 3. Okay? But the other two there is. 2 and 14, they're both even numbers, so 2 has to go into it. So if I do 2 divided by 2, I get 1. And if I divide this by 2, I get 7. Now, if I multiply straight across with what I have now, 10 times 1 is 10. 7 times 3 is 21. So we still get 10/21. That looks like a 4. We still get 10/21 either way. So whether we do the cross division or the cross reducing or whether we don't, we're still going to get the same thing at the end. Alright, this will be our last practice one before you try a few on your own here. And I'd put 3 of these on here and you'll see why in a minute. If you just want to do it normal and you just want to multiply straight across with no common denominators, which you don't have to have. 6 times 2 is 12. 8 times 4 is 32. Those, of course, could be reduced. I would say that we could probably divide by 4 on both of these. 12 divided by 4 is 3. 32 divided by 4 is 8. I get 3/8. There's my answer. Okay, piece of cake. Now, if you want to do the cross reducing, the cross division, if I have 6 and 4, well, they're both even, so 2 goes into those. 6 divided by 2, 3. 4 divided by 2, 2. Now, if I look at the other set that's diagonal from each other, 8 and 2, well, 2 goes into both of those as well. So I'll just make 8 divided by 2 is 4. And then I have 2 divided by 2 is 1. Now, if I multiply, 3 times 1 is 3. 4 times 2 is 8. 3/8. Now, the reason I wanted to show you another way is, let's say that you cross-reduced one of them, and you could have cross-reduced the other one, but you forgot or you didn't know it went into it. It's okay. It's still okay. Let's say you could only think of something to go into 6 and 4. Okay, 2. 6 divided by 2 is 3. 4 divided by 2 is 2. But you couldn't think of anything else to go into the other one. That's fine. We can just do it how it is. 3 times 2 is 6. 8 times 2 is 16. Now, that's not fully reduced. We could divide both of those by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. So even if you can cross-reduce and you forget to do one of them, you're still going to get the same answer no matter what, as long as you do it right. All right, I think we're to the point where you can try these on your own now. Again, you don't have to do the cross-reducing if you don't want to, or you can experiment with it a little bit, is fine. These are the 2 that I'm going to have you try on your own and stop the video. And again, please ask questions if you have them. Try these 2, come back to the video, see how you did. All right, this one looks like we could have done the cross-reducing in one of the spots. So I'll put it up here another time just so I can show you the difference between the 2 here. The cross-reducing would have worked with the 2 and the 10 because I could have divided both of those by 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. So there's our new problem. Okay, so if I do this one up here, 2 times 9 is 18. 5 times 10 is 50. And then we'd probably want to reduce that. And if we divided by dose, divided by 2, that's going to be 9/25. There's your answer. Now down here, I did that cross division, and you'll notice that 1 times 9 is 9. 5 times 5 is 25. That's your answer right away without any reducing. So that's your answer to the first one. For the second one, cross-reducing, let's see here. I guess I didn't really even think about this before I did to see if there was any cross-reducing. I just put them on there. Yeah, cross-reducing for sure. We've got 7 and 21. I know that 7 goes into both of those. So 7 divided by 7 is 1. 21 divided by 7 is 3. The other pair is not going to work because there's not anything that goes into 3 and 28. So we'll keep it like that for now. And actually, let's just do this one down here while we got it. 3 times 3 is 9. And 1 times 28 is 28. That's all she wrote for that one. I don't think we can reduce that at all. 9/28. Now, we got a pretty big one at the top here. 3 times 21, that would be 63. I got to find some place to put this on here. 63. Okay. And now if I do 7 times 28, that's, oh man, 7 times 28, that's going to be 140 plus 56, 196. Whew. Well, I know that the answer is going to be eventually this, but what can we divide by here? I don't know. I'm going to guess. Boy, I don't know. I'm going to guess, how about, let's try 7. Divided by 7. I think this is going to work, but it's going to take a little bit of time here. Yeah, I think so. 63 divided by 7 is 9. 196 divided by 7. Man, that's going to be pretty big. Let's try this out here. I know that 7 times 20 is 140. So then it would be 50. Yeah, it'd be 28. Yeah, so it'd be 9/28. And there's my answer. Now, I mean, of course, I'd want you to do that in a calculator, at least try it to make sure it works, but I'm just kind of figuring it as I go here. So my answer would be 9/28. So again, all we have to do for these multiplication ones, you can keep everything the same and just multiply straight across both top and the bottom. That's how it's different from add and subtract, and that's the toughest part about this. You've got to keep those things straight. You've got to have your common denominators for add and subtract, and you only add or subtract the top. But in multiplication, you just go straight across top and the bottom, and you don't worry about common denominators. You've got to come up with your own system to keep those things separate in your head, so whenever you see this, you can do it on cue.